For my final video, I'm going to show you how to convert from polar to rectangular and rectangular to polar. Now, first thing we need to remember some oopsies. Doesn't surprise you I did that. First thing that we have to do is think about how to connect r and theta with x's and y's. And actually, we've been doing this with vectors. If I were to draw a triangle and we call the leg lengths x and y, and then we have our hypotenuse, we're going to call r. Think about magnitude of a vector. And then we have our angle theta. There's some formulas that you will need to know and have memorized. First off, Pythagorean theorem. We got this. X squared plus y squared equals r squared. Second formula involves trig functions. We know that the cosine of theta is equal to the adjacent side, x, over r. And remember what we've been doing with vectors. If we were to solve for x and multiply both sides by r, we get that x equals r cosine theta. Totally like finding the x component of a vector. Well, same thing for sine, right? R, oopsies, blah. Okay, I think I should delete this video. I'm going to go with it. Y over r, we multiply both sides by r, and then we have r sine theta. Y equals r sine theta. Please note the time that it is that I am recording this video and give me a little credit. And then finally, the last trig ratio that we can come up with here is that the tangent of theta equals y over x. Now, I'm going to leave it just as that is because that connects theta with y and x. Now, I am going to show you how to convert. We'll do two problems together and then we're done, and then you have to complete the rest of this for homework. Starting with problem number 4, notice it says convert this ordered pair to polar form, which means our end goal is r's and thetas. Now, we are starting with x's and y's. Now, just think vectors. I mean, this is 100% vectors. All we're going to do is graph that ordered pair and think about how we can create this triangle. And remember that we could label the sides of the triangle. And we can find our hypotenuse just by using the x squared plus y squared equals r squared. So if you want to take that -5, square it, 5 root 3, square it, that's going to equal your r squared. And we can then get 25 plus, now be careful, we're squaring a product here. So think about squaring each of the parts. If I square the 5, it's a 25. But if I square the root 3, it's a 3. So what I end up getting is 25 plus 75, or 100 as my r squared value. Now, we're going to take the square root of both sides, and we're going to leave r positive. We're going to say r equals 10. Now, technically, yes, if you think about graphing up here, we could have negative r values. But we want to find the angle that would get us to quadrant 2 and keep r positive. So it'll take us to this point that we're talking about right up here. Now, final thing is to find theta, and this is again where we're going to use our tangent function. This is what we've been doing with vectors. We know that the tangent of theta equals y over x, or the opposite side over the adjacent. And then we can divide out, and we get negative root 3. Now, remember, we're thinking where in quadrant 2 do we get a tangent equal to negative root 3? So we need to think about y divided by x. Where does that equal negative root 3? And remember that if we don't want to flip the root 3, we want the y value to be root 3 over 2. And x, since we're in quadrant 2, would have to be the negative 1/2, and that'll give us that ratio. So we're really looking for that ordered pair, negative 1/2 root 3 over 2. So if you think about it, that's going to be your, 2 pi over 3 angle. So theta is going to equal 2 pi over 3. So we found our r, we found our theta. We can write that as 10 comma 2 pi over 3. Now, please note, you could technically write this infinitely many ways. I could make that a negative 10, but then I would have to go to the angle on the opposite side, 5 pi over 3. Final question, number 6, is to convert now from polar form to rectangular. What color should I go? Brown. Kind of how I'm feeling right now. What? Okay. I hate that this is going to be like forever recorded and that you can listen to this again and again and do something with it. I don't know. Anyway, this is your r, this is your theta. Now, you could set up a triangle and you can think about how when we had vectors where we were given the angle, we were given the hypotenuse, how we would go about, or the magnitude, I should say, how we would go about finding the x component and the y component. Remember, to do this, we are going to just take, and in the past, we, obviously the magnitude, but we're going to call that r value, negative 3, and we would multiply it by the cosine of the angle. And then to find the y component, we would do the same thing, but with the sine of the angle. Now, if these were on the unit circle, we would 100% find what that cosine of that angle is, sine of that angle is, and multiply it by negative 3. And in fact, you'll see some of the other examples that is the case. But for this one, it's not. So just make sure you go to mode, and you're in radian mode, and then we can find what each of these are, like we've been doing with vectors. How many times have I said that? I should go back and watch this video and do a little tally. Put a little tally like they do in jails, like every time I say the same thing again. All right, I better get better at making these videos because this is bad. Second pi divided by 7. All right, and then we get x is approximately negative 2.703. And then we can get our y value as well. So negative 3 sine negative 29 pi divided by 7. And then we get our y value of approximately 1.302. So if I write that out as an ordered pair, we can do that right up here. And then we're done. So please, for homework, finish the rest of the problems. My key is posted if you need any help, but it reviews everything we just talked about. If you have any questions, email me. And if not, bye. Bye.